this time I will ask you to follow me and to build something similar to what I'm doing in your Grasshopper, and then we will play with it during our session. So first thing I want just to show you, just not to show you, you have seen it, but just discuss. So for example, if I put a cone on my board, right? And I put a cone on my board, and if I enable preview for all elements, I will see a preview of this element in my Rhino space right away. So this element, like, it has been created when I placed it on the board, and the preview has been created in Rhino. Now I will take another element, box 2 point. And as you can see, nothing has been created in Rhino. So what's the difference? Why these elements behave so differently? And you see colors are different. So this one, like box, is colored red, and cone is colored, like, from my point of view, it's gray. I'm not sure how other people see this color. So what's the difference? The difference is that if we look at the cone element, we will see that some values are already predefined. So even if we do not feed anything into inputs in this element, actually this element has some predefined values, I would say, just for fun. So I don't think you will use this particular cone, you will need something else. So, but creators of this particular element, they define this element in a way that each input, if there is nothing fed into this input, it has some value in it. Like why it's 0.6, we don't know. It's something they came up with, but they predefine the values. And that's why this element works even without any input. And this element is different. So here, like developers of this element, they didn't define any values. So, and then this value is undefined, empty point parameter, probably because it's harder to come up with some particular points as inputs for a box, but that's how it is. What case is more general? I would say that an element without any predefined values is more general. It's a normal case. You have to provide some inputs. Just for some elements, developers provided, like, defined to come up with some predefined values. So why? It will become a little bit more clear why I mentioned that later. Now let's take some element. For example, we take a surface, we take a cone. We take a cone and we will do the same thing which we did previous time. We will start with it. So we will provide some radius, some slider for radius. We can play with radius. We will provide some slider for length. So now we can play with height, right? And we need base plane. Okay, we can, for example, we can give this point for base plane, set one point, with set any point, and and now we have this cone at this point in x, y, z0 plane. Okay, this is where we ended almost previous time. We came with some more complicated schemes. But basically, this is how we followed the path previous time. Now, let's do something unusual for like it's something which we didn't use previous time at all. Let's define another point. And let's add this point to the same input. For that, I need to hold Shift button. And now you see this input, we connected two inputs to this, two values to this input. And this is the result. So we've got two cones. Like they have the same radius, they have the same length, but they're at different locations. Now, you see, it brings like a different kind of functionality. Now this element, somehow it runs twice. It runs for this point and for this point, right? We can think about it in these terms. But now I expect you to come up with some questions, because you see, it's a new functionality, and I would expect you to question at least a few aspects of this functionality. Based on this example, what would you, like if it's possible to connect two elements to one input, what ideas you would come up with and what kind of functionality of this element you would question? Anybody? Any questions which you would, any kind of research you would like to do if it's possible to fit several values in one input? No?
Like I would be interested in seeing if you could have many, like basically like many, like hundreds of inputs, and if you could organize them in a certain way, like on a grid or something.
Oh, I see. So you mean, yeah, you mean architecture. I understand. So yes, we will come to it. So it will come to it certainly. So yes, it's possible to create structures, organized structures in space. That's Eric will show it later today. But now I mean like this particular, I mean the functional aspect of this element. So for now, it has two feeds on this input, and you see how it works. What other aspects of this functionality you would like to research?
Leo, I actually have a question about modeling what you have right now.
Okay.
When I put in, so I did radius and length, but when I added the first point, the cone disappeared.
Oh, yes, because you didn't fed this point with a particular value, right? Click this point, click set one point, and then choose a point in the Rhino space.
Oh, okay.
Okay.
Sorry,
okay, no problem. So this point element, it requires some something like you need to define the point. Okay, if nobody comes with the question, then I will question my own model. So for me, okay, I have two elements for one input. What will happen if I have two elements for the radius input? How they will interact with these two elements? I have no idea. Like exactly no idea. So I will have 2 and 2. Will they multiply? Like what will happen? All right. Okay, let's try it. Now I have 2 sliders and I connect 2 sliders to radius, right? Let's see how it will work. I will modify this radius. You see only one cone responds. I will modify this radius. The other cone responds. Was it expected? I would say no. Like I had no idea what kind of how it will work, right? So okay, it's interesting. So but then like why this radius responds to this cone and this radius responds to this cone? Any suggestions? Okay, I would say that okay, what I would say now, I would say, can you try to figure out, like, if you do have this, I hope you have a similar model on your space, in your space. Could you try to play, like you can delete a connection if you use control, right? You can add a connection if you use shift, you can add a connection, right? So can you try to play in your space with these elements, and can you try to understand, like to come up with an idea why, like how they correspond? Just try this. And you see, if, for example, I hover over a particular input, I will see a list of provided values. Like for B, I have values. For R, I have values. And for length, I also have one value because only one value has been provided. Okay, let's give it like a couple of minutes. If I hope that somebody will give a suggestion. Okay, any ideas? I hope you're all silent, so I don't have much feedback. So I hope that you were able to play with it. Yes, Annette?
Is it like the order that you connected in?
Yes. So in this case, you're absolutely right. So basically, the order you connect the element, it's the order which will be on the input. So basically, for example, input B, base plane, right? So first value is like first value for me is minus 42 something, and it is minus 4, just a moment, minus 4, yeah, minus 142, yeah. So it was the first point element which I created, and the second value is the second one. And the same thing here. If I reconnect them, for example, I delete this connection and I delete this connection. And then I connect them in, yeah, in different order, right? Yes, now they're switched. And now radius elements will control other cones. So yes, you're absolutely right. Yeah, it's the sequence of connection. So how it works? Now we can predict probably what will happen if we add another length element. So if we duplicate this length element, it will control the height of one cone, right? I mixed somewhere, yeah. And this one will control the height of this one, right? So then, okay, now we have 2 points on one input, 2 radiuses on next input, 2 lengths, and we more or less know how they work and how they correspond. What will happen if I create a third length? Let's try. And now that's, yeah, you see there's a smaller cone inside one of the cones. Yeah, so, and it is kind of like, and it can be like bizarre, like why it's all happening, why this cone, why there's another cone. So to understand this functionality, you should know the rule. So the rule is, like, there are two rules which determine this behavior. I would say three. First, each input can accept several values. So it can be more than one. And these values come in order. This order is determined by the order how elements were connected, or by the order of values. We can feed a list. It can be already, it can be just one connection, but several values can come over one connection in a sequence. So each input actually accepts not just one value, but a list of values. So sequential list. So some value first, some value second, comes in second, third, etc. Right? And each input, it basically accepts many values. So how many, it depends on your diagram, right? How you created it. So then what happens? This element, it works in sets of values. So it takes one value from the first position, then second value from the second position, third value from the third position in each of these lists. So if on B we have -4.13 in first position, -1.42 in second position, in R we have 0.60 something, 0.6 something in first position, 0, and 0.6 something, 678 in second position. Then for the first run of this element, first element on B will be taken, first element on R will be taken, first element on L will be taken. For the second run, second element on B will be taken, second element on R will be taken, second element on L will be taken. Now, L has 3 elements, and both other inputs, they have only 2. So Grasshopper will do the simplest thing possible. It will take the last element in shorter list, and it will duplicate it to the next position. Like basically the last element will go all the way to the longest, to make this list the same length as the longest input list. So in our case, the longest input list is this L, 3 elements. So basically B list will have one more, it actually has one more value, just duplicated last value. The same thing for R, right? So that's why here, this slider, that's why we have the same, we have an internal cone, because it is the second cone, which has this second value for B, second value for R, and this is this length which is applied to this element, right? Because like values are taken from the last elements on B and R. Is it okay? Now, is it digestible? Do you feel like you more or less understand how it works?
Yeah, so if we had like 4 lengths instead of 3, it would take the second point, the second radius, and then the 4th length. Is that how it works?
Just a moment, could you tell it again? Just
if length was 4, like we had 4
yes.
instead of 3, it would, so the 4th cone would be the second point, the second radius, and then the fourth length.
Yes, yes. So it will be now, like, let's do it. And actually, what I want you to try it in your, like, on your boards. So now you see this one varies, like this internal cone. Up, just I'm trying to zoom. Yeah. Now we have here 3 cones, one inside each other. It is what you expected, Annette?
Yes.
Yes, yeah. So it didn't, like, next cone, like fourth one, it didn't go to the first cone. The first cone, yeah, it's all last values, last radius, last base point. So they it's repeated for all, like, extra elements. Okay, good. So if you I would say play with it. I will continue building. I will build a little bit more. I will develop this model a little bit more, just to show how it can benefit us. But if you, at the same time listening to me, if you continue playing with this and trying to just trying your own combinations of inputs, and if you come across a problem, we can discuss it. Okay, what I want to do, I want to feed here, not just a moment, not predefined points. I want to generate these points. So how I will do it? For example, I'm taking a circle. I will create a circle. So, and I will take, yeah, it can be, I will put it somewhere. Yeah. So it is the plane, how it's oriented, and I will define some radius here. Okay, it's not the most. Just a moment. Let me see how I can make it a little bit more visual. Can it be? Oh, let me redefine the plane, otherwise we won't see it. Okay, 1, 2. Okay, it's better. So at least now we see this circle. Okay, what I want to do, I want to generate a sequence of dots. So I want to divide this circle. And you see I have divide curve element. So I will feed my circle into the curve. And I want to divide it. Again, I will use a slider. And I will define the slider. So no digits after dot. And let's say we will divide it from 2 to 15, just to keep it under control. So, and now we see, like, these are dots, so we can see the dots. And then we will feed, instead of providing points here, we will feed them into our cone element. So we see that our cones, they now they go around the circle, and we can, if we increase the radius, the range for the radius, okay. So now we can, for example, So we can have this sequence, and what we can do next, I think it's what we can do next. We can, for example, so we can increase the complexity. For example, we can play with the height. So, for example, we have what we have here. We have here 12 cones, right? We divided our circle in 12, right? And basically now, if we want to feed 12 elements into our length, for example, input. So how can we do it? We can use, like, it's amazing how many math functions and math structures Grasshopper supports, because it's a very important part of the functionality. Just let me see what we can use here. Here now, it was not here. Yeah, just a moment. Okay. Yeah, for example, we can use now, for example, what we can do, we already have 2 lengths, right? We have 2 lengths, but they're connected. If, for example, I disconnect them from here, and I will use a repeat sequence element, repeat data, right? And then I will feed these 2 into the data. So basically, now we have our data set is these 2 elements, and we want, and how many we have elements we want in our final pattern. We want 12, the same number as number of our divisions of the curve. And let's feed it into length. Okay, now when we vary the length, we will see that each second element, we are controlling the length of each second cone, right? So now, if we create patterns of the same length for different inputs, we will be able to play with the parameters, right? We can create now for the radius, for example, we can create a pattern in a pattern of 12 elements in a different way. For example, I can not playing with that. I can, for example, take Fibonacci sequence, right? I will take a Fibonacci sequence, like the classic one, and I will feed 12 elements into it. And then I will connect it to radius. It will be a very weird thing, because basically now radiuses are so big that we can see nothing. So we need to divide our Fibonacci numbers, and it's simple to do because we can introduce the division operation. So we will feed generated numbers into A, and we will introduce another numeric slider as a divider here. Edit, and it will be from, let's say, from 2 to 30. Okay. So, and now we want, it will be our divider, and then we will use this as the radius. So now if we decrease, so basically, yeah, now we are making our cones smaller. Still, some of them are very big. We can increase the radius here. Yeah. So, and then we have this different radiuses. Now we can vary length. Each second one will respond. And now we can vary radiuses, and then the whole sequence will be changing radiuses. And why here we have these duplicates? Because actually the Fibonacci sequence generates, we can check, it generates 14 values because this A and B, they are also added to the sequence, to the length of the sequence. So 12 other values, they're generated, and these two are extras. So basically, if we want the Fibonacci block to generate just 12, we need to use math to deduct 2 from our number of elements. Okay, and now we have 12 perfect cones which are changing, which follow some mathematical rhythm or mathematical law in how they change their parameters. Okay, so I would suggest you to try to build something like that with your elements and try to play with multiple inputs. It's already 40 minutes. So if like try to do something, let's say like 3-4 minutes. And if you have any questions or problems, just let us know. Okay. Okay, Eric, and then you can show something much more architectural than this, like mathematical stuff. Yes.
What is that? Like besides circle, like the input, the divide. Like where can I find that?
Just a moment. Divide, where you can find divide?
Yes.
It's math tab, and then in math tab you have operations, and in operations you have all mathematical operations. Like you can open the panel and you will see everything, including division.
Okay.
Is it correct? Like that's what you were looking for? Or you are thinking you want to divide the circle?
Yeah, divide the circle.
Oh, okay. Just, I found it. I just click on the board and then I click and then I type divide.
Okay.
And then you have divide curve. Do you have this element?
How do I search on the board? Oh,
just
find.
double click the board.
Oh,
double click the Grasshopper board.
Yes. Okay.
Okay.
Thank you.
Good. You're welcome. Just one thing I'm using from time to time, and I didn't explain. In Grasshopper, you have this icon only draw preview geometry for selected element, and if it's unchecked, then basically the geometry generated by each block will be shown. Sometimes it's useful, sometimes it's too much. That's why from time to time I just switch to the mode where only selected element is shown, and then I have to highlight a particular block to see what geometry is produced by this particular block. Are you okay if we continue, or you're finishing still? Okay, let us know if you have questions. Okay, I'm stopping my sharing, and now Eric can take over.
Cool. Do you guys have a class or something to attend to at 2 o'clock? Because this might go over a bit.
Ilse has.
Okay. Well, I'll speak as succinctly and concisely as possible. Okay, so this exercise, we're going to array a curve, and following the array, we'll look at its list to determine how we can remove specific items so that, removing specific items from a list essentially. So I've drawn a curve, you could draw whatever. And in our parameters tab at the top, we'll take a curve component, and these are containers. So they basically hold information from the Rhino space to be used as information in the Grasshopper workspace. So I'll take this curve component and right click it to set our curve. And whatever you've drawn in the workspace will now be referenced into this component. From there, we could double click or press spacebar to search for the array component. And what we're concerned with is rectangular array. And this might look different from, well, this does look different from Leo's display. So I like to use this type of display. If we go to the top and use full names, it'll give you the information about the input and output without having to actually look or hover over that letter. So I like to draw full names on, but it's a preference thing and it's up to you. So we'll look through the input items. So we need a geometry, which we have, our curve. We need a cell, which just defines the space between your objects in both the X and the Y direction. And then of course we need to specify how many items in the X and Y we want to include. So I'll take my curve and I'll join it to our geometry. And now when we right click our cell, we can set the dimensions of a rectangle. And this is going to be drawn. We have our options at the command bar to draw it in a specific manner. So I could choose 3 point so that I could select one direction like that, and then the next direction. There we go. And we've arrayed our items. This component has default values. So we have 6 in the X direction and 3 in the Y direction. We'll take a number slider, which made conveniently, to input into these inputs. And what I have is, if I right click and edit, I have a min of 0, a max of 20, and I've changed the numbers to integers so we don't have to deal with decimals. Okay, and simply connect 1. And you can see we've adjusted our X count. And you could do the same. You could copy and paste this and insert this into the Y count. But I'll show you that you could work with expressions with components. So instead of creating a separate number slider, I want to use this number slider as a reference to how we can determine how many Y counts of our curve to be arrayed. So I'll right click on Y count and head to expression, and this gives us a little tab to write an expression. So using X as our number slider input, we could do X plus 2. And so what that will do is it will create an expression that uses whatever value this number slider has currently and add 2 to it to determine the Y count. And so once I insert my number slider into this input as well, you'll see that we have 7 as indicated in the number slider in the X count and 9 in the Y count. And that should remain consistent as long as we have that expression in place. So that's just another way that you could modify however you're determining some inputs in your components. So you can also do, for example, X squared, and that should work as well. And however complex you get is up to you.
Sorry, Eric, one question. X, is it a predefined notation? So why, like,
Yeah, it'll be X. I tried Y. I tried having like two different number sliders and connecting it differently and doing X plus Y, but that doesn't work. You're going to use X as your value, which is determined by
so
a number
X,
slider or
so
integer.
again, so X is not referencing X count input of this element. X is
No,
referencing the value which is actually fed into this particular.
Yes.
Yeah. Okay.
Exactly.
Okay. Thank you.
So X is in this case our number slider. All right. Is everyone caught up? Good. Okay. I am going to, so we can hover over this output label at geometry to see our list. So we have 64 predefined values, and that means we have 64 of our array items. Or similarly, we can go to the parameters tab and input panel to select a panel component, and this can visually display what our outputs are. So we can see that we have a bunch of curves, and there is a set of 64 of these items. And even though it says 63 here, we start all our lists at value 0. So one item will be at value 0. And now we can try to modify this list. So everything that, when I select this component, all of these curves that have been arrayed are selected. But say I don't want to include several of these because these panels, for example, are on a facade and you want to create an opening at a predefined location. So we can go to the Sets tab at the top. Oops, did I stop sharing? We'll go to the Sets tab, and in sequence, there are three components that are useful for removing from a list. So we have these cull items. Let's select them all just to place into our workspace, and I'll talk about them one by one. We have our cull index, which just means we can remove a specific element or elements from this list, indicated by a number. We can remove it by every nth element. So if I were to insert 2, then I could remove every other element, basically. And with our pattern, we can become more complex and use a pattern of true, false, or zeros and ones to determine what is on and what is off. So I'll do the more complicated one. Let's do cull pattern. And here we have a list of 64 under this one set. So when I take my geometry, place it into list, our predefined pattern on Grasshopper shows that we have 2 false and then 2 true, meaning 2 are off and then 2 are on. So 1, 2 are off, 2 on, and then we repeat the pattern in this direction, so going up and reading left to right. To change this pattern, simply right-click over top, and we can set the Booleans. And how we set these are that every line is there a new item in the pattern. So we can do false and trues, or we could do zeros and ones. 0 meaning it's off, and 1 meaning it's on. So I'll just do a random pattern, and you guys can insert your own. And each value will be separated in its own line. So you have to press enter to read its own line. So now that I've created my pattern, you'll see that now it's applied to the array, and whatever is highlighted in this component will be what is created in our Grasshopper space. Everyone following so far?
I'm not really seeing the pattern. I just see like my arcs or my curves.
The regular rectangular array?
Yeah.
So what it might be is that visually this is over top of this pattern, and so you'll see everything. So what you'll want to do is select this rectangular array, right-click it, and unpreview it. Otherwise, this array will be over top your pattern, which you've removed some already.
Right. Okay.
So does that change it?
Yes.
Okay, cool. I will do another operation on this just to show you. Sometimes your lists might be like manipulated somehow, and you won't even know unless you have the panel option. So I'll double click to enter my search bar, and I'll type offset curve. And for this component, we have 4 inputs, our curves, which we can extract from our array, or sorry, our array. I'll hide this for a sec. Yep, our array and our, so that means we have to re-preview this. Then the distance of our offset from the original curve and the planes, which is already set to XY, so I don't have to touch. And corners just means it'll determine how that offset will be shaped. So it could be sharp or rounded, smooth, chamfered, etc. We don't really need to pay attention to these two at the moment, so we'll look at curve and distance. Using Shift and clicking, we'll drag this array to the curves. And using a number slider, I'll just borrow from this by Control-C and Control-Ving. We'll place that into our distance input. And you can see now that if we zoom in, we have an offset from our curve. And if we were to do the same operation where we would want to remove some of these items from the offset array, we could take call index, for example, and slot it in. And you'll notice that this line is a bit different and this operation is not working. Might be the reason is because you don't have a number slider, so it doesn't determine what item we want to remove. So if I were to put this in, that should work, but you know what? It isn't working. We're deciding to take, in this case, the 12th item of our list, 1, 2, 3, 4, 8, 12, and that should be removed from our array, but it doesn't seem to work. So let's take our panel component, let's copy and paste it, and this time insert it into our curves output of our offset. And you'll notice that these look slightly different. Here I have a set that has 63 or 64 items. And in this panel, we have 64 sets, each with their own item. And so that means one curve will be placed into one set. And so how our call index component is reading information is that it wants to remove certain elements from a list. But if you only got one element in your list, then it's not going to read a 12th item. So instead, we want to have our list to be much like how we generated our curves in our array panel. So if we head to our offset curve, we'll go to this curve output and right click it, and there's this option called flatten, and this will flatten all the data into a single list. And this will now look very similar to what we had initially, one set with 64 items in a list. And now this component called index can determine a specific item within this list now that we have it all compiled into one set. And yep, so now when we look into our Grasshopper Rhino display, we'll see that the 12th item is now removed and not offsetted in our selection. So one of the important things is make sure if something doesn't turn out right, for example, if it wasn't flattened, the operation would not execute. So I would suggest taking a panel and inserting it to the outputs of whatever is causing the problem and seeing if your list has been generated in the manner that your component has to accept that information. And yeah, even from the visual display of these links, we'll see that these are different from what we had in the output of our rectangular array. It's dotted, which means that we have multiple sets, as you could see from here. And each set is its own dark and yellow panel. Whereas in the rectangular array, we have a continuous double line, meaning that we have multiple items, but they're all within the same set. And just to further, we have just an individual item, so that's indicated by a single line, versus here we've generated 64 array curves, and that's shown by its double line link.
Yeah, I think we will need to talk about it a little bit more next time. Yeah, about sets and yeah, but it's an interesting example.
Yeah,
for sure. Yeah, it's a very good way to control, like to check what values are actually being generated. Yeah, that's an excellent example.
yeah.
Okay, I'm afraid that Ilse already should go to her studio.
Yeah, I have to go to class.
Okay, thank you.
Okay,
Thank you
yeah,
very
that's
much.
all.
Okay, yeah, good luck.